Have you ever wondered why some street lighting systems or outdoor lighting systems comes on at night and goes off during the day? These devices actually have a lot of potential application in the way we optimize the use of energy and also save cost of energy in our domestic use. In this video, we are going to show you a step-by-step approach on how to build a simple lighting control system using a transistor, a variable resistor, a light-dependent resistor, a diode, a relay, and of course, we are going to construct it on a breadboard. So this is a simple dark activated device. So in this dark activated device, we have a transistor, which is NPN transistor. We have a relay, we have a diode, we have variable resistor to adjust the sensitivity of the system. Then we have LDR. So the key to this dark activated device is the LDR. So LDR works based on the principles of light falling on its surface. So the brighter the light, the lesser the resistance, which means the resistance of an LDR increases with less light or decreases with increase in light in the amount of light falling on the surface. So which means the light intensity or the light falling on the surface is inversely proportional to the resistance. So in this configuration, it works as dark activated device. So this is what happens when the light falls on it. The resistance becomes smaller, and the voltage at this junction, we can call it VB, is less than 0.7. So when the light falls on it, the resistance drops. It will drop to a point whereby the resistance, the voltage at this point or at the base of the transistor is less than 0.7, which is less than the threshold voltage to bias the transistor or to make the transistor conduct. On the other hand, when the light falling on the surface becomes less and less, that means it's becoming darker, the resistance increases, and therefore the voltage at this junction VB will now be great once is greater than 0.7 volt, which is the voltage which is above the threshold voltage required to now switch on this transistor or a transistor. Then this transistor start conducting and the relay becomes activated. So basically the principles of it, the way the circuit works is based on the LDR, variation of light on the LDR, and the switching action of the transistor. So let me just explain why do we need this resistor. So we know that a relay is inductive, it has coil inside. So when you switch on a relay, a magnetic field is developed around the coil. So when you switch it off, those magnetic fields will now begin to collapse inside the coil. So by principles of Faraday's law and also Lenz's law, you'll discover that the collapse field or magnetic field now induce an EMF, which now flow through, and in most cases, because the induced EMF can be greater than the barrier voltage required to now damage this transistor. So also the essence of this diode is to now bypass the induced EMF back to circulate it. So which means the induced EMF will be circulating until it dies off. It collapses and the magnitude or dies off. Let me put it that way, because it can't sustain the oscillation since the source is taken away. So that's the essence of this diode. So it's actually protecting the transistor from the induced EMF as a result of electromagnetic field when the relay is on off stage. The component are selected based on the input voltage. We have 9 volts as our input voltage. So the variable resistor here is 10 kilo ohm, is to adjust the sensitivity of the LDR. That means as to be able to find a suitable point at which this transistor can trigger and now activate your lighting system when it's dark. So I'm going to show you how to construct this circuit. So here we are. Let's start constructing, but before we construct, let me briefly explain the component. So this is our LDR, light dependent resistor. It works by the amount of light falling on the surface, which varies the resistance. We have our 10 kilo ohm variable resistor. We have IN4001 diode. We have 2N2222 that's NPN transistor. Here we have relay. So let me use my hand to. So this relay, let me briefly explain. This relay has 5 terminals. We have, so in these 5 terminals we have this, and these are the coils, the terminal of the coils, while this one is called the common terminal. This terminal here is normally open, this terminal here is normally closed, so which means this terminal is common to this and this. So in this work, or in this construction or dark activated device, we are going to use normally open. So we are going to make use of the common and normally open, and these are the coils. So another thing we need is the power supply. We have 9 volt power supply here. The 9 volt power supply is to provide electrical supply to the electronic component. Then we have these cables here. This one is the cable that will now use to power the bulb through the relay. So we power the bulb using AC. We'll use AC to power the bulb. So what the relay does is that it acts as an interface. It now separates AC from DC or DC from AC. It allows the electronics component to now control the AC part. So in essence is that this relay effectively isolates DC from AC. So that's the essence of using this relay. That's why we use the relay to drive the AC load. So having said this, let me go ahead and start constructing. So let me start by placing my 10 kilo ohm variable resistor. This is the 10 kilo ohm variable resistor. The second step is to put my LDR on the board. So this is my LDR. So this is my LDR. So in case you miss how to place your component on the board, you can click the link on in the description. So the next step is to now take one terminal of your LDR, not the middle, either left, the one on the left or the one on the right. So you can take any of them and connect it to your VCC. So I'm using this section as my VCC, while this section as my ground or negative. So I'm connecting one terminal of the variable resistor to my VCC. Then the second step is to connect the other terminal of the variable resistor, that's the other free end, not the middle one, to the one terminal of the variable light dependent resistor. Then the other free terminal of the light dependent resistor, you connect it to the ground or your negative side of your power supply. So we are going to use this our NPN transistor. So how do you connect it? So between the junction between the variable resistor and the LDR, we now take it to the base. If you are following the circuit diagram, we'll see that the junction between the LDR and the variable resistor is connected to the base. So this is the connection to the base. Then the next step is, since we are biasing this transistor as NPN, and in case you don't know how to bias NPN transistor, you can also check our previous video on how to bias NPN transistor. So for NPN transistor, your emitter is connected to the ground, or the negative side of your power supply. So with this connection, we are good to go to connect our diode. So notice that a diode has a mark. There is white mark. The terminal where this white band is located is called the cathode, while where the majority of this terminal is called the anode. So anode, cathode. So the mark indicates the terminal is actually a cathode. So let's connect the diode to let's connect the anode of the diode to the collector. Then the other terminal, then the other side of the diode, which is the cathode, is connected to the VCC. So it's connected to the VCC. This connection is okay. So we'll go ahead and connect the relay. Already I have a relay that I have soldered. So the reason why I solder it is to avoid partial contact on the AC. So as I earlier mentioned, we are going to use normally open contact. So this is our common, this is our normally open contact. So we are going to now connect this normally. One side of the, you can take any of them, either the common or the normally open, and connect it to the lamp holder. So I'm connecting it to the lamp holder. Then we have this supply, AC supply. So we are going to connect, we are going to now connect this, the other cable from the relay to the to this cable. This is our supply, AC supply. While trying this out, don't forget to follow all safety precautions to avoid any incident or fatality. Are properly insulated, so you can properly insulate them to avoid electrocution, and also to avoid the AC part touching the DC. So you can see that this is our supply from AC. So one terminal is connected to the relay, and the other end of the relay is connected to the lamp holder. So the other part of the supply, AC supply, will now go to the lamp holder. Our next step is to connect the coil of the relay. So I'm using this to connect. This is the coil of the relay. So I'm connecting this to the coil of the relay. So I'm using this to now connect. So let me use this to so let me explain. So once this one is connected to the coil of the relay, make sure that it's firm. Make sure that it's firm. So now one terminal of the coil, which is this, goes to the collector of the transistor. The other terminal of the coil, which is here, is connected to the VCC. So it's connected to the VCC. So before we use AC to power it, let's use DC to test our control to see if is working. So this terminal goes to this, that which is our positive, this is our negative. So everything is okay, our control is okay. You can hear the clicking sound. It shows that once there is shadow over the LDR, the transistor is biased and the relay is energized. So this is what it means. So let's go ahead and connect our AC supply. So you have to take appropriate precaution because the relay is naked. So now let's see how it works. So so you can see. So this is a simple dark activated device that you can use to now develop your automatic street lighting system or outdoor lighting system. So once it's night, it comes on. Once it's daytime, it goes off. Once it's night, it comes on. Once it's daytime, it goes off. So this is how you can use effectively use LDR, transistor, and a variable resistor to now build a simple dark activated lighting system. So this has a lot of application, not just for creating or building automatic street lighting systems. You can actually use it for counting in production line, to count the number of items that's passed through a production line. So you can use it to count. So it's basically, you can use it as a counter, or you can use it as part of automatic street lighting control.